Hi everyone. Our project we are doing is a group D, and what we are trying to answer is a question: can the news about trade tensions actually help predict what happens to prices? So, does the trade tension sentiment help predict commodity price futures and inflations? Uh, we measure the pass-through from U.S. to China tariff news all the way to consumer prices using a tool we built called a Bilateral Trade Tension Index, the BTTI. Okay, I'll set up why this matters, and then my teammates will take you through the data, the method, and our findings. So why does this matter? The news moves before the actual shock does. So first, a decade of trade shocks. US-China tariffs are defining trade shock of the decade from the Section 232 and 301 tariffs in 2018 to 2025 Liberation Day tariffs, which pushed the cumulative rates on Chinese goods to 145%, the highest since the Smooth-Hawley era. Second, policymakers need lead time. Central banks need early indicators of tariff-driven inflation before it shows up in the CPI. By the time it's on the official data, it's too late to get ahead of it. And the third, the gap we target. Traditional macro models react only once tariffs are implemented, but markets react earlier to the news, the rhetoric that precedes policy. So can news-based signal give policymakers a head start?
Walk you through our research questions. A primary question is this: does media-derived trade tension sentiment Granger cause commodity future prices? Our hypothesis is yes. We expect sentiment to lead futures prices at 1 to 5 day lags, peaking at around 1 to 3 days, moving ahead of realized policy changes. We also have two secondary questions. First, is the price response asymmetric? Specifically, do tariff-protected commodities like steel and aluminum react differently from retaliation-exposed commodities like soybeans? We hypothesize that negative shocks push protected metals up while pushing retaliation-exposed agriculture down. Second, does adding our index, the BTTI, improve CPI forecasts beyond standard models? Again, our hypothesis is yes. Adding the smooth BTTI should reduce out-of-sample forecast errors for CPI. To answer these questions, we built a pipeline from three data sources. First, GDEL 2.0 for new sentiment. We collected bilateral US-China trade events from 2015 to 2026, strictly filtered by trade and tariff keywords. Second, Yahoo Finance and the World Bank for commodities. We use daily futures for 10 commodities to capture immediate price shocks, plus monthly spot prices for 8 baseline commodities for structural comparisons. Third, Fred for macroeconomic contours, monthly CPI, PPI, treasury yield spreads, and inflation expectations. As you can see in this diagram, each source goes through its own download and processing script, and everything is merged on date into a single method dataset, 131 rows by 32 columns. With that, I'll hand it over to the next section.
This slide introduces the Bilateral Trade Tension Index or BTTI. It is constructed from daily detailed event data and combines three signals. The first is the conflict rate, which is the share of events classified as conflict. The second is a negative Goldstein score, which captures the hostility of events weighted by how often they are mentioned. The third is mention density, or the volume of trade-related media coverage. We standardize these three measures using z-scores and combine them with equal weights. Therefore, a higher BTTI indicates that trade-related events are more conflictual, more hostile, and receive greater media attention. As the figure shows, tensions were especially elevated during the 2018 to 2020 trade war period, and the index rose sharply again in 2025. Overall, the index broadly captures major episodes of US-China trade tension. This slide summarizes our methodology in three steps. First, we examine short-run price predictability using daily Granger causality test. We test whether past values of BTTI help predict movements in commodity futures over 1 to 5 trading days. We also conduct reverse direction tests and apply stationarity treatments when necessary. Second, we examine short horizon asymmetry. Using daily OLS predictive regressions and short-mean analysis, we estimate the responses of 5 commodity futures to daily changes in BTTI over 1 to 3 day horizons. We then compare whether metals and agricultural products respond in different directions. Finally, we assessed the forecasting value of BTTI for CPI. We compare a baseline macroeconomic model with an augmented model that includes a lagged 3-month moving average of BTTI. Forecast performance is evaluated using RMSE, MAE, and the Diebold-Mariano test.
Now, I will discuss the results of a primary hypothesis. Our hypothesis was that the Bilateral Trade Tension Index, or BTTI, would predict price movements in tariff-exposed commodity futures 1 to 5 trading days before actual tariff policies were implemented. As shown in the heat maps, we found significant granular causality only for corn and soybeans, both at a 1-day lag. This means that increases in trade tension reported in the news are quickly reflected in agricultural futures prices. However, steel and aluminum did not show any significant relationship at any lag. This was surprising because these were the commodities directly targeted by tariffs. One possible explanation is that metal prices are influenced more by domestic supply conditions and energy costs than by trade-related news sentiment. Another important finding is that when we repeated the analysis using monthly data, the significant relationships disappeared. This suggests that financial markets absorb trade-related news very quickly, making daily data much more effective for capturing these short-term effects.
On to our secondary hypothesis, we now test whether trade tension moves commodities futures prices asymmetrically. We expect negative sentiment shocks to be associated with metal price increases due to tariff protection and agricultural product price decreases due to retaliatory tariffs. To test this hypothesis, we conducted OLS shock tests on 15 pairs of variables. More specifically, we had BTTI as the independent variable and 5 different commodities futures prices as the dependent variables at 3 different time horizons. If the hypothesis were true, we would expect to see a positive coefficient on metals and negative coefficient on agricultural products. However, the results contradict the hypothesis. Generally, there is no significant response to BTTI shocks, and additionally, most coefficients are positive across commodities and forecast horizons. Subsequently, when we separated the trade tension shocks into 2 different bins, one for small or no change and one for large change, we observed that all 5 commodities earned positive returns on days with large shocks. On potential explanations, for metals, tariff protection could already be priced in, so daily BTTI shocks add no new information. Additionally, tariffs also raise costs for downstream buyers, potentially suppressing demand and offsetting supply-side benefits. For agricultural products, corn demand is more domestic, therefore retaliatory tariffs may have had more minimal effects. On the other hand, for soybeans, China shifted purchases to Brazil, tightening global supply, and as a result, other buyers had to rear their right and compete for US soybeans. For the next secondary hypothesis, we move on from commodities price futures to CPI. Our hypothesis is that adding the BTTI to a baseline CPI model would reduce forecast errors of tariff-exposed CPI categories. To test this hypothesis, we forecasted CPI with a base model using PPI, treasury spread, and inflation expectations. Subsequently, we added a lagged, smooth BTTI variable to the augmented model. Then we conducted our sample forecast using an expanding window and obtained the root mean square error of the forecast. Our results support the hypothesis for food and core CPI, reducing the RMSE by around 4% and 1% respectively. Headline CPI exhibits a non-significant directional improvement, while energy CPI shows no improvement. On potential explanations, food and core CPI reflect goods most exposed to trade policy-driven import cost changes such as processed foods and consumer goods. Meanwhile, energy prices might be more determined by global supply or demand shocks, not bilateral tariff policies.
Let me summarize the key discussion points and limitations of our study. First, a VTTI remained close to zero during most periods, with sharp increases only during major tariff escalation events. This indicates that the index captures short-lived episodes of trade policy uncertainty rather than long-term economic conditions. We also found that significant relationships appeared only in the daily analysis, not the monthly analysis. This suggests that markets react to trading news almost immediately, highlighting the importance of using high-frequency data when studying the effect of trade-related events. There are several limitations to our research. The GDELT database includes all trade-related news, not just market-moving events, which may introduce noise into our sentiment index. In addition, monthly aggregation may hide short-term price movements. Our expanding window forecasting approach may not fully capture recent structural changes, and the relatively small number of major trade war episodes limits the statistical power and the generalizability of our findings. Overall, while our results are encouraging, future research with more refined data and additional trade episodes could further strengthen these findings.
When it comes to policy implications, our findings carry several policy implications. First is the BTTI is an informative forecasting tool. Because it grandeur causes certain commodity futures prices, it shows that markets respond to trade news before tariffs are formally enacted. When added to a standard CPI model, it also improves forecast accuracy for food and core inflation. Second is this suggests that policymakers should monitor the flow of news and not only enacted policy. Agriculture futures incorporate trade tension news within a single trading day. So an index like the BTTI could signal price pressures before they appear in official CPI releases. Third is the fact that the asymmetric effects across sectors are theoretically motivated, but we had difficulty to establish them empirically. In principle, U.S. tariffs raise domestic metals prices, while Chinese retaliation lowers agricultural prices. We could not identify this pattern cleanly using a single composite index, and we present this as a limitation rather than a confirmed result. To conclude, the two of our three hypotheses were supported. First is the fact that agricultural futures respond to the BTTI within a single trading day, and the index meaningfully improves forecasts for food and core inflation. The third hypothesis on asymmetric effects was not supported. We had expected metals and agriculture to move in opposite direction, but most commodities move the same way. We view this as an informative result since it shows the conventional framing is too simplified to capture actual market behavior. Our findings motivate three areas for future research. First is the sub-period analysis, which means that separating active trade war episodes from calmer periods would allow us to test whether pass-through is state-dependent. Second is the use of higher frequency inflation proxies, maybe like weekly measures could capture faster pass-through than monthly aggregation obscures. This is consistent with our finding that significant daily relationships disappear at the monthly level. Third is extending the analysis to additional bilateral country pairs would allow us to assess the generalizability of the signal beyond the US-China context. Thank you very much for your attention, and we welcome any other questions if you have.